So in pie chart, we have pi and pi 3. Pi is for 2D, pi 3 is for 3D. Okay, so I have prepared you a data, a matrix like this. Okay, so each column of X contains yearly sale figure. Okay, so this one column here is a yearly sales figure for a specific product over a 5-year period. Okay, so this is first year, second year, third year, fourth year, fifth year. Okay, so this is a yearly sales. Okay, this is a yearly sale for a specific product. Okay, so maybe product 1, product 2, product 3. Sum each row in X to calculate total sale for each product over a 5-year period. Okay, so we do X is equal to sum X. Okay, so the total of all of the value of X. Okay, then you can offset the slice of the pie that makes the greatest contribution using the explode input argument. Okay, this argument is a vector of 0 and non-zero value. Non-zero value offset the respective slice from the chart. Okay, so we're going to look at that later. Okay, so first we create a vector containing 0. Okay, so explode is equal to 0 size X. So you see here, this is size of 5 by 3. Okay, 5 by 3. So we use here explode matrix of 0 size 5 by 3. Okay, then find the slice that contribute the most and set the corresponding explode element to max. Okay, so we put that C offset max X and we explode offset equal to 1. Okay, so the explode vector contains the element 0, 0, 1. Then to create the exploded pie chart, we use the statement H pi X and explode. So we put it as color map summer. Okay, color map summer, you will get like this. So you see here, this one we explode it, then we separate it from the rest of the chart. Okay, we put it, explode it and separate it from the rest of the chart. Okay, open your MATLAB. Okay, open your MATLAB. Okay, please comment all this. Please comment. Okay, so look at the bottom. Okay, look at the bottom and comment this first. Okay, this is actually, okay, let's say this is the data, okay, for X and pi X. Okay, so they will produce you, okay, the data of pi X. Okay, this one of the pieces is, we don't have any value, okay, pi X. Okay, so let's say we want to do it in 3D, we use this pi 3X. Okay, so you will get like this, okay, in 3D. Okay, but MATLAB we specify, we put the all of the percentage value. Okay, although you not you not specify it. Okay, so here. Okay, so this is the basic pi coding. Okay, this is the basic pi coding. Okay, so here we have X here. Okay, so we have 5 by 1 matrix. Okay, we have 5 by 1 matrix. Okay, so uncomment here. Okay, so we have a matrix of and what my workspace is, so I hide it. Okay, so this is okay. Then you use explode. Okay, we use explode. Okay, we use explode to find the zero matrix of size X. Okay, then we use C, we offset. So which means that C offset maximum X then we explode offset is equal to 1, then we do P is equal to pi x explode, then we do color map is in summer. Okay, so this is the summer color. Okay, so what if you don't want to do this explode thing? Also can. Okay. Okay, also can. Okay, comment this. Then just write pi x. Okay, so you get the same. Okay, so this is like normal thing to say, like if you don't want to explode it, like take the slice out from the pie chart. Okay, so let's say, okay, let's say you want, okay, go back to your PowerPoint slide. Okay, so now here you can look like this. Okay, it looks like this only. Okay, with the same page only. Okay, now we want to label product A, product B, and product C. Okay, how are you going to do it? To label it. Okay, to label the graph, the pie chart label a text graphic object. Okay, to modify the text string, we use this because it is a object, right? It's a graphic object, so we write p text. Okay, is equal to find object. Okay, so what is object? It is p. Okay, so if you notice here, we use here p is our pi x. So we want to find objects of p. Okay, we want to find object of p, type text. Okay, so we want to add text in our object. Okay, text is what is our percent values equal to get p text, then for is string. Okay, so percent value get p text. Okay, then string. Okay, so which means that we start with the text this first. We start with this. Okay, then followed by the percent value. So we do product X colon, product Y colon, product Z colon. Then we combine the text. Okay, this one str cat is a string category, text percent value. So which means that product X followed by percent value, it combined. Product X 42%, product Y 30%. Okay, so P text 1 dot string combine text 1, P text 2 string combine text 2. Okay, so which means that product X 30%, product Y 40%, something like that. P text 3 is combined text 3. Okay, because this one is considered as an object. Okay, it's not like previous histogram, bar chart, and all. You just have to specify the position, the coordinate. Okay, but this one, because it's object, so you need to specify more. Okay, so let's do it. Okay, uncomment this. Okay, when you run it, you see here, product X 25%, product Y 34%, product Z 42%. Okay, you can explore, okay, by using legend, okay, to represent your pie chart. Okay, to present your pie chart. Okay, next is when you want to remove a piece from a pie chart. Okay, when the sum of the element in the first input argument is equal or greater than 1, pi and pi 3 normalize the value. So given a vector of element, each slice has an area where xi is an element of x. The normalized value specifies the fractional part of each pi slice. So when the sum of the element in the first input argument is less than 1, pi and pi 3 do not normalize the element of vector. Okay, so you see here, okay, they draw a partial pi like this, okay, 0.19, 0.22, and 0.41. Okay, when we do pie chart here, okay, you will not get a full one because, okay, it's not equal to, it's less than 1. Okay, the vector is less than 1. Okay, I think I have shown you before. Okay, so let's say I have this. Okay, you see here, this one, the pie chart is one of the slides is removed. Okay, so usually when we do pie chart, I don't think we have this kind of pie chart, but if you have it, okay, this is how you do it. Okay, so, okay, any question about pie chart? Pie chart? No? Okay, so open your MATLAB. Okay, so open your MATLAB. So here, okay, let's say you want to do here, P, okay, so you do pi 3. Okay, you do explode, you use the explode function by using 3D. Okay, you see here, it will be like this. But I know this view is not that good. You can use, adjust your azimuth and elevation, okay, to rotate it a bit. Okay, so this is a pie chart. It's not necessary for you to do the explode thing, but if it is required, that's how you do it. Okay, so next we're going to the histogram. Okay, the code that related to histogram is, I already give it to you, C6 histogram. Okay, MATLAB histogram function shows the distribution of data value. Okay, the function that creates histogram. Okay, we use HIST, H-I-S-T, and polar histogram. Okay, HIST, H-I-S-T displays data in a Cartesian coordinate system, but for polar histogram, it displays data in a polar coordinate system. Okay, what is polar coordinate system? Okay, we're going to look at that later. Okay, histogram function counts the number of elements within a range and display each range as a rectangular bin. Okay, the height or length when using polar histogram of the bin represent the number of values that fall within each range. Okay, so they do the class. Okay, same like how you do in statistics. Before you do a histogram, what you do? You do a class, right? So any frequency that falls within the line, okay, would be the will, okay, and sorry, the class, okay, the number of frequency that happens in that respective class will be the bar. Okay, then his function shows distribution of the elements in Y as a histogram with equally spaced bin. Okay, so in histogram, okay, the bins is equal interval. Okay, between the minimum and maximum values in Y. If Y is a vector and is the only argument, histogram creates up to 10 bins. Okay, they create up to 10 bins. Okay, so let's say we have this yn, we put a random number, 10,000 random number. Okay, then we do histogram yn. Okay, 10,000 random number, create a histogram, okay, with 10 bins distributed along the x-axis between the minimum and maximum value. Okay, please copy this and put in your MATLAB. Okay, so this one is the random number, 10,000 random number. Okay, so then they group it together and put in 10 bins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so by default, they will create you into a 10 bar, 10 bins. Okay, so here, okay, we have the minimum and maximum. So we create a random number from -4 until 4. Okay, but yeah, and then it's a maximum and minimum. Okay, so we get something like this. Okay, so when you want, okay, when you want to input into the matrix, histogram creates a set of bins for each column. Okay, displaying each set in a separate column. Okay, let's say we have random number 10,000, but we have 3 sets. So which means that we have 3 sets. Matrix A, matrix B, matrix C. Sorry, it has 3 random set of random number. Okay, then say you copy this, then put in teams. Okay, comment the previous one first. Okay, so you see here we have 3 categories of random number. Okay, here also we have 10 bins. Okay, we have 10 bins for each. Okay, we have 10 bins for each category, for each category. You can put it on. Okay, so this is a histogram, okay, for use matrix. Okay, now we want to know what is the histogram in polar coordinate. Okay, we have a rose plot is a histogram created in a polar coordinate system. Okay, for example, we generate 10,000 random number. Okay, to display this data using the rows function, we have convert the data into radian, then use the data as an argument to the rows function. Okay, so we have to convert into radian, then we can use the rows function. Increase the line width property of the line to improve the visibility of the plot. Okay, because the histogram also we have to use the find object. Okay, then we use polar histogram. Why? The H line find object GCA. Okay, type line and set the horizontal line with a 1.5. Okay, you will get the output like this. This is a polar histogram. Okay, this is a polar histogram, or we call it as yeah, we use rows function for this. Can you copy the code and put in your MATLAB? Okay, you will get like this. Okay, so this one is polar histogram. The histogram is plot according to the polar. Okay, but as a statistician, for me, we don't need this. Okay, I just want to show to you. We don't need this. Okay, we don't need this. Okay, because it's in radian. How are you going to, explain it, right? Hmm. So this one I just want to show to you. But in reality, the application actually is not that friendly for us to use in statistics. But I'm not sure if it is very well used in maybe meteorological or geology or any science thing. Okay, any science field or but both statistical and mathematical, we don't see it as very important. Okay, but I just want to show you how you're going to plot it. Okay. Okay, now, okay, we know that by default, the number of bins created by the MATLAB is 10. Okay, but somehow we need it more or we need it less than that. Okay, we need it more or we need it less than that. Okay, like this is more than 10, right? Okay, so what you can do is we have to specify number of bits. Okay, so histogram and polar histogram interpret their second argument in one of two days as the location of the axis or the number of bits. When the second argument is a vector, it specifies the location on the axis and distribute the elements in length bit. When the second argument is a scalar x, histogram and rows distribute the elements in x bit. Okay, so for example, to compare the distribution of data created by two MATLAB functions. Okay, so we have RAND-N, which is generate normal distribution. We have RAND-D, generates uniform distribution random number. You know normal distribution, right? Normal distribution number can be from negative to positive value. And this one is uniform distribution. Usually it is a positive number only. Okay, so please do YN ran N 10,001, YU ran. Okay, this is random number uniform. This is random number from normal. Can you copy it and put in your MATLAB? Okay, so let's say, okay, I want to look at the, okay, this is a random number from normal distribution, and YU is the random number from uniform distribution. Okay, so you see this is uniform, okay, and this one is random. Okay, again, it's the same thing. We have a 10 bins for each. Okay, we have 10 bins for each. 1, 2, 3, 4, 10, and 10 for normal. Okay, same. This is like default setting by the MATLAB. Okay, default setting by the MATLAB. Okay, you can specify it by using, okay, the first histogram displays the data distribution resulting from the Rn function, and the location on the x-axis and number of bins depend on the vector x. Okay, x we can put as minimum yn until maximum yn, and increase by 0.2. Then we use subplot. Okay, subplot because we want to see in the same plane. Okay, then we put title and subplot 1 to 2. Okay, then this one, second histogram displays the data resulting from the random number function explicitly creates 25 bins along the x-axis. Okay, because we do histogram YU 25. 25 means we create 25 axes. Okay, sorry, 25 bins. Okay, okay, copy all this and this into your MATLAB and please run it. Okay, so this for X, okay, we do, okay, minimum and maximum, and it increased by 0.2. So 0.2, all of the bin is increased by 0.2. And this one, if you count it, the bin is 25 because we use this 25. So this is how the two ways. This is two ways that you can specify the number of bits. Whether you use histogram, then put number of bits. Let's say this one is 25, then you do it. Or another one, you can use the maximum and the minimum. Okay, maximum and the minimum, then increase by 0.2. Okay, so if you use this, it is more suitable. Okay, if you use this to specify the bin, it is more suitable for detailed data. Okay, if you are suitable for detailed data. But for this one, okay, it is suitable if you want to see the overall of the data, the pattern of the data. Okay, so it is up to you how you want to specify the number of bits. Okay, but if it is like not a critical one, you just use this 6, 25 bits. Or if you are more specification, because normal distribution, you want to see how normal is the curve, right? So that's why you use every number here is every bin here, minimum until maximum, then we use the interval is 0.2. Okay, do you get this plot? You get this plot? Sorry. Wait. You get this? Yeah. Okay. Girls at the back, do you get this plot? You get? Okay. Everyone got it? Okay. Any question for histogram? Okay, I think it's quite easy. Okay, quite easy. Okay, so you can do it. Okay, next is two-dimensional stem plot, 2D. Okay, a stem plot displays data as line, terminated with a marker symbol at each data value. Okay, so we have stem. So in a 2D graph, stems as stem from the x-axis, and the stem function displays two-dimensional discrete sequence data. Okay, so let's say we have this. Alpha is 0.02, beta is 0.5, t is the number from 0 to 200 with the increment 4. So we do exponent alpha times t times cosine beta times t. Okay, so use a vector of discrete value for y at a given values of t. Okay, so a line plot shows the data point connected with a straight line, but a stem plot of the same function plot only discrete points on the curve. Okay, please open the stem plot coding. Okay, open the stem plot coding. Okay, so here you want to see if you use the plot that you learned before and also the stem. Okay, you see it. If it is the plot, okay, if it is the plot, okay, you see it is like this. Okay, but if it is like in a stem, okay, they plot it a discrete data. Okay, not discrete data. They plot the same function only discrete point on the curve. Okay, only discrete point on the curve. So this on the right side here is the stem plot. Okay, so this is the normal plot, normal line. Okay. Okay, you can, oh sorry. Of course, you can specify the line style, type of marker, and color used in stem plot. Okay, let's say if you use this column SR, specify a dotted line, square marker, and red color. Okay, so then the field argument colors the face of the marker. Okay, can you copy this? This one is dash. Okay, can you copy this and put in the put it in your MATLAB? Okay, so this one means the line here that I want to use is dash, that is a dash. So dash dash, okay, S is square, R is red. Then we want to use fill. What fill? Because I want to fill up the marker. Hold on. Okay. Okay, so this is a stamp plot. Okay, we use square marker, red line. So this is a stamp plot. Okay, this is a stamp plot. You can, okay, let's say you want to do circle, you can also zero. So here. Okay, so if you did not specify it, it will become a normal line. So you can play around. Okay, how to use the stamp plot. Okay, so next is to customize your graph. Okay, setting the aspect ratio of the x and y axis to 2 to 1 improve the unity of the graph. Okay, you can do this by setting the aspect ratio of the plot by using PB aspect. Okay, by using PB aspect. Okay, in normal plot, you use D aspect, right? Okay, and this one is you use PB aspect. Okay, this is equivalent to setting the plot box aspect ratio property directly. Okay, so we by setting the aspect ratio, it should PB aspect to 1, 1. Okay, so can you copy this? This, okay, and put a, these two are the same. Okay, these two are the same. Okay, maybe you can use the bottom part, then put it in your code. Okay, so you see here. So, okay, okay, so here I do the aspect, okay, for my y. Okay, so it become here 2, 1. Okay, this one 2, this one 1. Okay, to make it. different perspective. Okay, so this one is I want to show you the difference between this. Okay, so I use set GCA plot box aspect ratio 2:1:1. So which means that okay, it's 2:1:1, guys. This one is 2:1:1. Okay, and next is to combine stem plots with line plot. Okay, to combine stem plot with line plot. Okay, so it looks like this. Okay, it looks like this. Okay, how to combine? This is stem plot, and this is a normal plot. This one you use stem, this one you use plot. Okay, the one that you learned before. Okay, so let's do one by one. Sometimes it is useful to display more than one plot simultaneously with a stem plot to show how you arrive as a result. Okay, for example, we create a linear space with 60 elements. Okay, we use function A and B. So we have function A, sine x, function B, cosine B. Okay, x is we create a linear space from 0 until 60. Okay, sorry, 0 until 2 pi, and the interval is 60. Okay, so you create a stem plot showing the linear combination of the two functions. So we create stem handle is equal to stem x a plus b. Then we overlay a and b as a line plot, have visualize the function. Here we have to use hold on. Okay, here we have to use hold on. Okay, open your MATLAB. Okay, so please copy the one in your notes and put it in your MATLAB. Okay, then you use hold on. Okay, you use hold on. Before plotting the curve, you have to use hold on. Okay, so MATLAB does not clear the stem plot. Okay, you use hold on, you use plot handle, plot x. Okay, plot x. Okay, the x, A. What is A? A is sine x. Okay, that a dash red. So red line, dash line, red dash line, B blue, red dash line. Then you put hold on. Okay, and use legend to annotate the graph. Okay, so stem and plot handle pass to legend, identify the lines with the level. Stem plots are composed of two lines. Okay, one draws the marker and the other draws the vertical stem. Okay, copy this and put in Teams. Put in MATLAB. Okay, so for your stem plot, we use x a plus b, the value, and for plot x, it is sine x. For plot b, is a cosine b. Yeah, good. Okay, so we use legend. Okay, so what you use to create legend, use the first handle written by stem, which identifies the marker line. Okay, legend handle is stem handles 1, followed by plot handles. What is plot handle? Okay, which is plot X and plot A and B. Okay, legend is legend handles A plus B, A sine. This is the legend name, and B is equal to cosine X. Okay, and then you put the X label and Y label to finish the graph. Copy this and put in Teams. put in put in the in your MATLAB. Okay, hold on. Okay, there's a, okay, I copy this code and put in Teams. I run using the MATLAB online. It is okay, but this one maybe not sure why. But okay. Okay, so this one is the graph, okay, for the for this okay, wait. Wait again. Wait, hold on. Okay. Okay, please refer the latest one. Okay. So here is the plot. Okay, when you overlay it, you just hold on. Okay, you use plot handle. Actually, you can do plot handle 1, plot handle 2, but for the legend, you just have to specify. But this one, I show you how if you combine it, these two plots. Okay, so we use that the stem plot is A plus B. Okay, A sine X is denoted by the red dash line, and cosine X denoted by the green. Okay, the green dash line. Okay, do you get like this? You get the output like this? Yeah? Okay. So now, okay, this is the stem plot overlay with the line plot. Okay, overlay with. So how to do the 3D stem plot? Okay, stem 3, display 3D stem plot extending from the XY plane. Okay, with only one vector argument, MATLAB plots the stems in one row. If x is equal to 1 or y equal to 1, depend on whether the argument is a column or row vector. We use stem 3, okay, to intended to split the display data that you cannot visualize in a 2D way. Okay, in a 2D way. Okay, so this is example of 3D stem plot. Okay, using the fast Fourier, okay, transform. Fast Fourier transform calculated at points around the around the unit circle on the complex plane. Okay, this is mathematics or physics. Okay, so it is interesting to visualize the plot around the unit circle. Okay, so we create a value of TH, okay, unit circle. This is the, from number 0 to 1 to 7 divided by 128 times 2 times 5. Then we do x as cosine this value and y is the sine this value. And the magnitude, frequency response of a step function. So you have absolute value, okay, fast Fourier transform. Okay, so 10 row, 1 column, okay, for 128 values. Okay, display the data using a TD template, terminating the stems with fill diamond marker. So we use stem 3 XY, okay, diamond, and we fill it. Then we use the view negative 65 to 30. Okay, so this is a 3D plot for the fast Fourier transform. Okay. Can you open the MATLAB? I have prepared a code for you for the 3D stem plot. Okay, so if you run it, okay, you will get the view like this. Okay, so this one, the marker we use diamond. Okay, you can change it. Then we fill the marker. So we use fill, FILL. Okay, so what if you don't use view? Okay, if you don't use view, okay, you get like this. Not much difference. This way you can see. Okay, so this is a fast Fourier transform graph under the circle. Okay, under the circle. Okay, any question? As long as you can plot, I'm okay. Okay, you don't have to know what is fast Fourier transform. Okay. 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 Now we want to combine stem and line plot. Okay, similar like this. Okay, but this time around we're going to use stem 3. Okay, with line plot. So we're going to do something like this. Okay, but don't worry. Okay, for your assignment, we don't do something like this. Okay, you just have to plot your game outcome, not do the something. Okay, so let's do it. Three-dimensional stem plots work well for visualizing discrete functions that do not output a large number of data points. So you can use stem 3 to visualize the left-least transform basis function. So we use y equal to exponent st and constant value of s. Okay, but constant s is 0.1 plus I, imaginary number, y is. Okay, then t is 0 until time, the increment is 0.1. So we use t as the magnitude, the increase with time. Okay, so which means that 0, then 0.1 second, 0.2 second until time. Okay, create a spiral with increasing height and draw a curve through the top, okay, of the stems to improve definition. Okay, so please copy this and put in team and this one. Okay, please put in team. Okay, so here, we plot using stem plot stem 3. We use real y, okay, which means that only real number, okay, and then real number, and then they plot it against imaginary y. Okay, so real, this one imaginary, real, which is the x, y is the imaginary, okay, t is the magnitude. Over time, when it increases from 0, 0.1, then 0.2, 0.3, until the last one is 10. Okay, when z is 10. Okay, so we use plot 3 also. Okay, plot 3 is the line here, the red line here. Okay, to plot a real number and imaginary number, okay, according to the time, the magnitude. Okay, then we view, okay, I rotate it a bit because I want to see this view, and then I label X, Y, and Z. Okay, don't worry, MATLAB will understand your coding if you use for on. So it's just you has to plot which comes first. So this one, we do stem first. Then after that, on top of it, we use plot. Okay, so plot will come after. So that's why you see here, the red line is on the top of the stem. Do you get it? Yeah. Sorry, today I didn't walk around because I want to finish chapter 6 fast for your assignment that we release on Friday. Okay. Then now, okay, any question for the stem plot? Any question for the stem plot? No? Okay. Stair-step plot. Stair-step plot display data as the leading edge of a constant interval, like 0 or the post state. Okay, this type of plot, it looks like this, like staircase. Okay, it looks like this. It's like a staircase. Okay, stair-step plots displays data as the leading edge of a constant interval. This type of plot holds the data at a constant y value for all values between xi and xi plus 1, where I is the index into the x data. This type of plot very useful for drawing time history plots of digitally sampled data system. Okay, this type of plot I use for my survival model. Okay, for my survival model and for the actuarial model because it's a time history plot. Okay, so how to do it? Okay, let's say we have a function f rise over time. Okay, so it's exponent alpha t times sine beta t. Okay, what is t is 0 to 10. What is alpha? 0.01, beta is 0.5. And after that, we use stairs to display the function as a stair-step plot and a linearly interpolated function. Okay, open your MATLAB. I have prepared you stair-step plot. Okay, I have prepared you stair-step plot. Okay, comment this first. Okay, we use stairs to plot TL. Okay, so you will get like this. Okay, you will get like this. Okay, you will get a plot like this. And next is, okay, we use stairs to display the function as a stair-step plot and linearly interpolated function. Okay, we want to show you Okay, another overlay plot line that is linearly interpolated function. So what we do is, okay, we use fold on. Okay, we plot TF. Okay, here we use the mark dash 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 line. Marker is tau. Okay, marker is tau. Then we use fold on. Okay, so you see here, okay, is only the marker only plot the beginning edge of the stair step. The beginning edge. Okay, it not plot this side, only plot on the beginning here. Okay, if you remember OGIF and frequency polygon, okay, you will use this in 6.3. You will use this in 6.3. Okay, so this is a step. Okay, then we put a label. Okay, and we put a text label for x and the axis. We specify it to be 0 until 0, 10, negative 1.2, 2.2. X is 0 until negative 1.2. Okay, so here. Zero, 10, negative 1.2 to 1.2. 0, 10 is for x, negative 1.2 to 1.2 is y. Okay, so this is another way for you to specify your axis. Okay, to specify your axis rather than use minimum plus 0.5, maximum minus 0. Minimum minus 0.5, maximum plus 0.5. Also, you can do it. But this one also like the easier way, okay, to limit your axis. Okay, so if you notice here, I use here as label step plot of this one, exponent negative alpha t sine beta t. Okay, then my text here, I put it at 0.5 here, is located at 0.5, negative 0.2. So here, okay. Then the text is I put here is equal to label font size 12. Okay, this is another way for you to add your text. Okay, rather than you put everything here, you dump everything, your name, your type, sorry, your name of the label here. Instead of it, you can also do like this. Okay, this form. Okay, so this is many way for MATLAB to use it. Okay, but I think like Java, like Python, C. Okay, we don't have many alternative as MATLAB. Okay, we don't have many alternative. It's like this, and it's not fit the condition. It's error, error, error. But in MATLAB, is the programming is very. It's not very, but it's user friendly. Not very user friendly, but it's user friendly. But I think R is more. You have to specify and tell them a bit by bit if you don't use package. But if you use package, it's still okay. Okay, so this is the step plot. You have it here. Okay, we finished 6.2. Any question? Question? Okay, I give you 10 minutes break. 10 minutes break. We begin at 3:30 before we start with 6.3. Thank you.